Okay, so here's what I'm thinking. I wanted to, just for your thesis for whatever it is, 8 months from now, I wanted to go over what the niche overlap stuff and how you interpret it. And so that we have this again for later, I'm recording it. So I'm going to be like opening up the files on my screen here, but we'll have this video later and go back and look at it again. So the basic idea is this: there's these numbers. I'm trying to keep close to my computer. These statistics, I and D, they're just two different ways of trying to measure the same thing. It's just some people say, well, you should use this math. Some people say you should use this other math. The thing they're trying to measure is niche overlap. So the idea is when you do ecological niche modeling, you get the you get the map that you're used to looking at, the heat map, and it's also in the form of an ASC file. That's the thing I was telling you about, trpt.asc and txpt.asc. But it's just a file where at every pixel, it's got a score for how suitable that habitat is. Unless there's no habitat there, like we only modeled the rivers, so there's a bunch of like areas where it won't give a score. But anyway, so if you have two niche models, so if you have two so it's always so you do this test for niche overlap, you have to have two things that you're comparing because you have to see how much they overlap, right? So in this case, we're comparing Texas pigtoe and triangle pigtoe, and if they had exactly the same niche model, in other words, if those ASCII files that came out the other end had the exact same scores, so like if imagine like position like A14, and let's say the score there was 0.19, and A14 in the other model it was also 0.19, and you went through point by point, and like the two always matched up exactly, so they were just copies of each other. That would mean that they have identical niches. And the score that you would get using I or D would be 1. Let's say that the scores at those identical spots on the landscape were always different. So let's say that if the habitat suitability was really high for the Texas pigtoe at that spot over there, let's say it was always really low for the triangle pigtoe at that same spot over there. So let's say that was always different. Then the math would work out that the niche overlap score would always would be 0. There'd be no similarity in the niches between those two things. Okay. But then in between 0 and 1, there's a big mushy middle, right? Where there's somewhat different, somewhat the same, but it's worse than that. Think about how niche modeling works, right? You're taking some points that you just have available where you know that the species occurs, and you've got your habitat, your layers, so you find those associations and you make a forecast. It's just estimated based on the points that you gave it, right? I mean, so the niche model that you get isn't going to be perfect. So imagine if you take the same zebra species, but you use two different sets of points, you're going to get two niche models that are a little different. It's not because those zebras are the different species. It's just because you used, because the points you used were different going in. Your estimates for the two niche models are going to be a little different. Not a lot if it's the same species of zebra, but there's those niche model ASC files are going to come out a little different. The suitability scores are going to come out a little different, right? So that's the problem, is that even if you take the same species of zebra, if it's different points you're starting with, your niche overlap score when you're comparing those two different sets of models that you made are going to be, it's not going to be 1. Your niche overlap score is going to be, I don't know, 0.9 something, whatever, but it's not going to be 1. So then let's say that you want to know if your two species really do have different niches, which is what we want to know. Yeah. So how different an overlap score, so how far away from 1 does that overlap score have to be before we're confident that, you know, that those two muscles really have a different niche, that they're really different, right? So let's say we took the niche model for Texas pigtoe and the niche model for triangle pigtoe, and the niche overlap score is 0.94. Okay, it's not 1, but I don't know, it's pretty close to 1. So how do we determine if it's close enough to 1? Do we say, well, those niches are pretty much the same? You know, that's within the margin of experimental error just from using different points. They probably just have the same niche, right? So how far away from 1 does that number have to get? That's what this is all about. So the first part of this that you did a few weeks ago was actually not, it wasn't using your real data. The first thing we were doing a few weeks ago generated this file called identity _ Texas pigtoe versus triangle pigtoe sorted.csv. And I'll go ahead and open that. And to make a long story short, what you did there is you set up the software to do a bunch of runs of Maxent, not with your real data, but with random data. And then it compared the niche overlap. Then it ran it again on random data, compared the niche overlap. And it did that 100 times. And so what we're doing here in the sorted file is we're looking, if we go to the 1, 2, 3, 4, 5, if we go to the 5th element down in the list, that means that 95% of the other runs were even higher than that. Not important. That generates for us a critical value. So this number here, for example, for I, which is 0.84, is how different you would expect if you took your zebras and you just took some random points where you know that, you took some points where you know the zebras exist and some other points where you know the zebras exist, and you did your niche model separate. That's how extremely different your niche models could be. And it's still really, it's all the same niche. You could get an overlap score as low as 0.84, and that's close enough to 1 that we still say it's like 1. Anything within 0.84 and 1, anything within that range close to 1, means that those niches are statistically the same. Any overlap score lower than that means that those niches are so different from one another that it's not due to just the fact that you sampled different points. There really is an ecological difference in those niches. So anyway, the important thing to remember here is what you did a few weeks ago in that analysis with this file, identity, Texas pigtoe versus triangle pigtoe sorted, is you generated your critical threshold. You used what's called simulated data. You can think of it as random data. Instead of with real Texas pigtoe and real triangle pigtoe, you used these random points, and then made niche models based on it and compared the niche overlap. And we used those random models to give us our critical threshold. All right. Now, what you just did today is you took the results from your real ecological niche models on your real data, and you found what the real niche overlap scores are, both for I and for D. The data is formatted a little different, so it gives us two different spreadsheets, but it's all there. So if we look at I, it's formatted really weird, but there's just that one number in there, 0.8839, blah, blah, blah. Okay. And then we'll open up the one for D. Again, there's no reason to prefer I over D. It's just those are two different ways of measuring niche overlap. And so it's always safest to just present both of them. And that's why we're looking at both. Okay, so here for D, the niche overlap value is 0.65. So those are your real niche overlap scores. So then here's the rule that you apply. Let's go back to our spreadsheet of critical values. So for I, if the critical value of let me start here. Hold on. Actually, it's better if I start here. If the, let me go to the, so okay, so this one that you did today that has your real overlap score measured with I, I'm calling that your empirical I score. So the number that I see there is 0.8839. So that's your empirical I. If your empirical I value is greater than your critical I value, so the critical I value in this case, reading off of this chart is, and this is from the spreadsheet, identity, blah, 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 sorted. I see that the critical value is 0.08412. So we have our empirical I, which is 0.8839. We have our critical value based on the simulations, that's 0.8412. If the empirical I value is greater than the critical I value, you accept the null hypothesis. So the null hypothesis in this case is that the niches of the two species are not significantly different from one another. And the alternative hypothesis, and I have this all here, I'll give it to you, is that the niches of the two species are significantly different from each other. So you've got those two things. So if the empirical I value is greater than the critical I value, you accept the null hypothesis that the niches of the two species are not significantly different from each other. If the empirical I value is less than the critical I value, then you reject the null hypothesis and accept the alternative hypothesis, which in this case is that the niches of the two species are significantly different from each other. So the bottom line is you have these numbers that you generate in these different places. You take the numbers, you apply this decision rule, and the answer that you get at the end is whether the niches of the two species are significantly different from each other or not. All right, so I'm going to have you look at the decision rules here for a second. And I'm going to just show you here. So here is so at the bottom there are I empirical and I critical. And there's your decision rules.
So we accept the null.
Yes, correct.
Okay.
So you accept the null hypothesis. So just to reiterate, the empirical I value was 0.88. The critical I value, which we got from the chart that's open on your screen right now, is 0.84. And the rule is, if the empirical I value is greater than the critical I value, you accept the null hypothesis. And since 0.88 is greater than 0.84, we accept the null hypothesis. Yeah, and then it's the same for D. So now we'll just do the same thing for D. So our critical D value is much lower, but it doesn't matter because we have to evaluate our critical value relative to our empirical value. So our critical D value is 0.5714. I bet you already know what the answer is going to be because these things, the I and the D almost always end up telling you the same thing. So you're not going to be surprised by the outcome. Here we are. So our empirical is 0.625 and our critical is 0.5714.
Okay, so same thing, we
So,
accept the null.
So it's the same thing, so we accept the null hypothesis. All right, so I will give you this, a link to this so that you have it for the future, and there we go. Got to figure out how to turn it off.